Hello and welcome. Thank you for coming. My name is Alexis. I work at Google in the cloud organization, and today I will be talking about serverless and its different aspects, as well as how it fits into the DevOps world and how you can combine the two, because I think you can actually do that, and it's a great opportunity to start focusing on things you might not have been focusing on before. So I've just deployed a new version of my demo. I hope this was not a bad idea, but I guess we'll see. We'll talk about the nuances, I think, of serverless. We'll talk about serverless and operations. And we will talk about some of the best practices that we've developed at Google in the form of SRE, or System and Service Reliability Engineering, and how to survive in the serverless world. And I'll show you some of the tooling. But I think most of the presentation is relevant to anything serverless, mostly in a public cloud environment, but hopefully some of it also applies to some of the on-premises solutions, such as Knative, Riff, OpenWhisk. There's another really interesting talk I suggest you should go and listen to if you're interested in serverless, which is about Project Riff built on top of Knative. This is done by my colleague Ray and the Pivotal folks. So I'm one of those fools who started using, or who used serverless in the title of this talk. So I guess I need to explain what I think is serverless. Clearly, there are servers, okay? You just don't get to manage them. It's really an operational model. No server to manage. So that means the infrastructure security concerns, for example, are dealt with. The other aspect of operation is that you can scale to zero, and you don't pay for idle time. So you really only pay for usage. And there's no cost for, if your code isn't running at any point in time. So that's pretty normal, and that actually is a very broad definition of serverless, and I think most people will agree to that definition. The second part, which I'd like to think about, is the programming paradigm, probably as a developer. First of all, and this could be considered to be a cloud-native way of developing apps, as opposed to lift and shift. Take your application, 3-tier, whatever it is, take it on virtual machines to the cloud. This is where you make that shift, and you actually take the approach of doing something that's really cloud-native that will give you a lot more benefits because of all the nice things that a cloud has to offer. So the services part is interesting because that means you really want, instead of carrying along lots of libraries, lots of runtime, you want to reuse other services. Similarly, you want to expose services. So maybe we're talking microservices here, and this talk is not about that, about finding the right granularity in the dependencies, or dependencies write things or not. I don't know, but really it's more about getting a service for persistence, for example. Give me that service as opposed to here's a URL to a specific machine to listening on a specific port. I really want a database service, whatever it is. Just give it to me. And I don't know where it's implemented. I just want to use it. And the other part, which is really important in serverless, and certainly when you get to talk about functions as a service, is the event-driven aspect of things. This is where you get to have things that are essentially very loosely coupled, event-driven, and all those services are orchestrated by a series of events. That looks very nice on paper. In practice, that also means you need to have some of the tools to understand what's going on and to manage all of this. And we'll get back to this. So, but going back to the serverless definition, which is, you scale to zero and pay for what you use, that could apply to compute. That's what we'll talk about, but it can apply to many other things. Databases, database as a service should be something that you consider as serverless. Nobody uses it. You might pay for storage, but you don't pay for the traffic going in and out and for all the compute and the queries coming to it. Messaging, storage, you could think of something where you store data in buckets as serverless. And that's all good, and I think that actually is all serverless. But we'll focus on the compute aspect here. Just to give you an example, in the context of Google Cloud, which I know best, obviously, we have actually two options for compute part. We have things to cover everything I just described, but for the compute part, let's focus on that. We actually have two products, so why two? Well, at the end of the day, it really comes down to what is the artifact that you as a developer want to give me so that I can run it in a serverless fashion? Would you like to give me a function, a collection of functions, which are fairly short amounts of code? Maybe they have dependencies on them, maybe they don't, maybe they're just glue code, maybe it's a full-blown application if you know how to structure and manage that complexity. Or you want to give me an app that's built out of services that have versions, that have dependencies. Maybe those services are actually even written in different languages, in which case you give me an app, and I will run this with something called App Engine. So that's really nice, but I'm sorry, going back to functions here. Functions is really respond to events. This is really the canonical use case here. Events trigger functions. Of course, an HTTP call could be an event. It's kind of a special case of that. But something that's uploaded to a bucket, something, a data changes in a database, a message is posted to a queue, somebody authenticates, a user is created. Anything could be an event in the system or in the broader cloud environment that you use could be an event that triggers a function. And that function, hopefully, is not too big of a code. It talks to other APIs, creates some kind of response, and sends it back to the cloud service that either emitted that event or to somebody else. So that's the basic thing. Hopefully, you have a choice of programming languages for function. The libraries and the developer experience matter a lot. Do you need to wait like minutes for it to deploy, to test it, or do you have a local environment? How quickly can you iterate? This is all really important. And the performance of the whole thing running, especially the cold starts, which is something in serverless which we probably all know about, which is, I'm spinning up new instances because this is auto-scaling, but the new instance needs to warm up my stack. And if I use a lot of libraries, well, starting one instance could take too long, and that could be perceived on the other side by your users. Really, it's a gateway to the cloud in general. It's an amazing way to leverage the features of any cloud, I believe. In case of Google, if you want to talk to a machine learning API, you'll see a demo, just write a simple function, and that function already runs in the cloud. It's on the network, it's already authenticated, and you can make really easy calls to lots of different APIs just by having that function there. Lots of events, that's the key to success, I think, to event-driven serverless and functions in particular. And of course, let's not forget all the monitoring and the management that needs to be in place, and that's part of the talk coming forward. If we get to the application part, maybe you have something that's more structured. It's not glue code. It's really an app. It has a front end. It has a back end. It might have different services, different versions for those services. You might be willing to try different things as you deploy. Maybe you want to do canary releases, A/B testing. These are all the things that we have App Engine for, and that's really important. Maybe those services are microservices. I'll let you decide and choose that. But really, that's how we see the difference between functions and applications. And this typically will have an HTTP front end. The unit of deployment is the application. You still have a choice of language, and you have features such as versioning and traffic splitting, and you'll see in the demo how that can be useful. So really, I can deploy functions, apps, but what about containers? Everybody uses containers nowadays somehow. How many people are using Docker today, one way or another? Yeah, I mean, it's most of the room. Maybe that's what you want to give me. Maybe not just a bit of code as a function or something that's more elaborate and an app. Maybe you want to give me a container. Well, that is something that we're working on, and the industry is working on, I think, not just Google. So one thing we have in early access today is the ability to deploy a container in the same runtime as what we use for functions, and to run this in a serverless manner, which is scaled to 0, which is something that by default something like Kubernetes cannot do, for example, and only bill you for when it's used, and scale, obviously have the auto-scaling implemented as well. If you're interested, there's a link here. The other thing is you might already have Kubernetes. You might have already invested in it. You might have actually people that know how to operate this. Maybe you're leveraging some GPUs or TPUs, tensor processing units, in that infrastructure in your existing cluster. Well, on top of that, you can deploy something we call the serverless add-on. which will provide a serverless environment and experience to developers on top of an existing Kubernetes cluster. And this is built on Knative, which is this project that was created and announced a few months ago, started by Google with a number of partners such as SAP, Red Hat, IBM, Pivotal, SAP, which provides on top of Kubernetes using CRDs a number of primitives such as build, serving, events, which provide that serverless environment on top of Kubernetes. All right, serverless. It's a horrible name, really, because it defines something by what it's not. So, and a lot of people make jokes about, yes, there are servers. And I actually had colleagues at Google ask me, you know, they're in a totally different part of the organization, completely. They're in mobile. Asked me about serverless, and they were serious. They were like, they really thought there were no servers. So it's a horrible name. So let's see, can we come up with something better? How about no ops? I mean, it's all about not having to operate these servers. That's really trying to capture the fact that as a developer, you don't want to deal with this. You want to deal with your app and iterate over it and deploy new features and focus on code, not on the infrastructure. Well, turns out it's not a whole lot better. Because, well, first of all, it's also defining something by what it's not. And also because there are operations. Of course, I mean, you have to operate your service. That's you know, implying that operations could go away is kind of misunderstanding ops in general and DevOps in particular. So, sorry, I don't have a better name. But what I do have is some of the best practices that Google has been developing in a serverless environment internally. It is very much serverless. There's no such thing as a server. You just get resources that are part of a global pool. And while it may not always be functions or app engine per se, everything here has been developed by Google for many years and is, I believe, applicable to serverless, which can be a little tricky to manage. And you know, what is tricky here? Well, first of all, by definition, the servers are not accessible. You cannot install an agent for your favorite monitoring app. Sorry, that is not possible. And the favorite monitoring app will change every 6 months anyway, so don't do that. You can't SSH into the instances. Sometimes you can, but it's really just to get a read-only look at things. Otherwise, you're going to be creating snowflakes, and it's probably not a good idea. The second thing is, it's all about auto-scaling. If you want the economics of cloud to work for you, you want to be able to shut down stuff when it's not in use so somebody else can use it. And you want to have the highest density on a given piece of hardware. So it's really important that you do implement auto-scaling. It's not just for you, so you don't pay when it's not used. It's also for the cloud provider to have the best possible utilization and provide you in return with the best value and the best cost. But what that means is that you can never rely on the fact that you hit the same instance the second time around. This is where you have all these best practices about being idempotent, about making sure you never assume you have a session going on and you can go back to the same instance. This means that tracing between services and things going up and down all the time can be a little tricky. So you need to understand what's going on and how you got to a certain point. Now, when you talk about services or microservices, they can operate and be scaled all independently. You want to be able to trace calls between services, and that really becomes critical. So beware also of cascading failures. That is something that can happen, and you need to understand how it happened and how to make sure that it doesn't happen again. And finally, the whole aspect-oriented thing, where an event happens in the system somewhere which triggers something else, which does some compute, might trigger something else, is also asynchronous by nature, and it also might be more difficult to understand and to analyze. So again, you want to know how you got to a certain point, and you want to be able to have a global view. So serverless is nice, but it does come with a number of challenges, and Some of it is from breaking down into a monolith into microservices. Some of it has to do with the nature of serverless altogether. So to illustrate the rest of this talk, I would like to introduce you to Pick a Daily, which is a very clever name for a demo, which my friend Guillaume and I built, which you can use, and which is essentially a photo sharing app. So it's accessible now. You can either scan the QR code or hit that URL. It's a progressive web app. It should work on your laptop, but on your smartphone as well. No app to install. It's just a web app. And each photo you take is uploaded, and we analyze it. We send it to the Vision API, one of the machine learning APIs that Google offers, which returns a number of things, such as the dominant color, a number of tags about what it sees in the photo. And since this is user-generated content, and I'm sorry I can't trust all of you because I don't know all of you, I need to scan those pictures and make sure they're safe to show on a screen like this one. And if not, they go into a queue, and I get to moderate this. So that's basically what the app does. It also calculates the most popular tags based on what the Vision API returns. And I have this ability to actually filter and moderate what's being uploaded. So clearly people are using it. I can see it already. Thank you very much. The way it's built is using both App Engine and functions. So it has a front end, which is built in Java on App Engine. This is what receives this is what is serving the page that you see, and which receives the uploaded images. This is then being dropped into a bucket in cloud storage. And that same front end also updates a data source layer with the most frequent tags and some metadata. The event-driven logic is handled by functions, as you would expect. These functions, in this case, happen to be written in Node. And this is where the call to the Vision API happens, and that returns all the data. This is how we populate the metadata, which is read by the front end. And we also have another thing that happens that is being triggered every 5 minutes, I believe, which is to compute the most popular tags. You don't want to do this all the time. So we post a message to PubSub. That message is being consumed by another function, which will go ahead and update that tag cloud with the latest values. We use different languages. Oh, and there's the admin app, and that app is written in Go. So we use different languages, Node, Java, Go. And in the case of App Engine, it's really just one app with multiple services. And each service has different versions, and as you'll see, it has an importance. This is fully serverless. There are no clusters, no instances to manage. I'm just deploying code, sometimes an app, sometimes a function. So that was a quick intro. Hopefully some people get to exercise the app, and we'll come back to it and hopefully show some interesting things. So how do you leverage Google's experience of running services at massive scale? When we hear DevOps as a term, we often equate this to something we call internally SRE, or Site Reliability Engineering. It's a title at Google. People can be software engineers, they can be many different things, or they can be site reliability engineers. It's a very highly respected role at Google. These people are software engineers, but they're tasked with what used to be called operations. I think DevOps has been around for more than 10 years now, and SRE has been around for maybe that or even more at Google. And really, they're very similar. They're so similar that I think you can state the following, which is, you hear DevOps, we understand SRE. That's our implementation of DevOps. There can be other implementations of DevOps. They're totally fine. We use SRE internally. When you say DevOps, we think SRE. In fact, the industry seems to have adopted SRE as a term also, and other companies such as Apple, Twitter, Facebook, Amazon, Oracle, GitHub, they all have SRE teams, and they call it that. So at Google, SREs are really a very important piece of running everything we do. Google has 8 products that serve 1 billion users each, and that's all managed by a few thousand SREs. And you think about it, that's a few 100,000 users per SRE. So that's not a lot. So when you look at this, you need to do 2 things. You need to manage reliability, and you need to allow for agility. Because if you want to be super reliable, you never change anything. That's it. You're done. But the chances of being able to keep up with the competition, ship new versions, new features, well, if you can't change anything, that's a problem. So the SREs need to balance these 2 requirements. So it's really important that you have a culture in place. We've tried to share that culture that we've developed at Google through a number of books and literature. And I'll have links to those 2 books, which you can get to online for free. And it's really important. The goal is not to be ops in a traditional way and just to carry a pager and run around and put out fires because a disk is full, something goes to 100% CPU, or you want to automate yourself out of the job. You want to make sure you are not woken up in the middle of the night. So try to automate everything that's repetitive. Auto-scaling is an obvious example, but that's pretty basic. There are many other things that they do. The other thing that the SREs can do is refuse to carry that pager. Because the app you've built, well, they've not been involved well enough, or they're not happy with how it can or cannot actually be managed. So at Google, there are teams that run their own stuff because they weren't really good enough, especially in the early days of developing their system, to earn the services of an SRE or a team of SREs. So SREs are responsible for on-calls. They do carry the pager when they agree to. They're also responsible for producing what we call blameless postmortems. Something bad happens, and something bad will happen sooner or later. What we want in the blameless postmortem is to make sure it doesn't happen again by understanding what happened and making sure we don't point fingers to any particular team or person. It's a really important part of the SRE culture. The second element is the infrastructure. Remember how many SREs we have? We have a lot more software engineers. In fact, we probably have, for one SRE, about 10 software engineers. So one SRE cannot go and talk to the 10 engineers and tell them, please log that value, please expose that metric, please do this. So you need to instead be very opinionated about the things that need to be baked into the infrastructure. So any service has to have, obviously, a name, it needs to be discoverable, it needs to have quota, it needs to have permission, and there needs to be some base telemetry out of the box always. This is really important. This is what a cloud provider does for you. We have an internal cloud provider which is helping Google deliver its services, but a cloud provider, whichever it is, should be doing that for you and exposing some base telemetry for anything you deploy. And here we have 2 open source projects we're working on. One's gRPC and Open Census, and essentially these are open sourcing or new projects, such as Kubernetes was internally known as Borg. These projects are essentially recreating and open source what we have internally at Google. The third one is a platform that will capture all that data, potentially massive amounts of data. It's kind of a time series database that other tools will tap into to provide useful information and insights. It's important, but if you don't have the infrastructure in place, that platform is useless, and so are the tools. The tools are really just the tip of the iceberg. Yes, you can have graphical tools that can help you analyze data faster, but really you need to have everything starting with the culture before any of the rest can actually happen effectively. So going back to the culture of SREs, here are 3 terms. Who's heard of SLA before? Hopefully everybody. Like, service level agreement. You as a developer might not be involved in this, but somewhere down the road, you're delivering a service. If it's business critical, there's probably an SLA attached to it of some kind. So remember I said SREs don't run around just putting out fires because some CPU happened to go over 80% or some disk is full. Sometimes even a disk that's full, which shouldn't happen, isn't impacting the business. So you might as well fix that later, not now. So the SREs really want to look at and fix what impacts customers, users of the app. So a CPU that goes to 80%, we've implemented the obvious thing of having auto-scaling. So there's really no need to do anything there. Of course, they could go and look into what's going on and see, but there's no point in paging people just because of that. So instead, what we define is SLIs, or service level indicators. That are indicators that actually affect customers. And 2 obvious examples are things like availability. I'm hitting server errors, so it's not delivering the service, so it's not available. Or latency. It's taking forever to send me an answer. And maybe sometimes it's an error. So what is the percentage of my requests that come back with responses in less than 300 milliseconds? That could be an SLI that you want to look at. An SLI could be very business-oriented as well, but these are the obvious ones, availability and latency. Now, what is SLO? And impact the customer and the business. So what's an SLO? Well, once you've identified an SLI, you can make a promise to yourself. That, for example, 99% of the calls will come back in less than 300 milliseconds over a given period of time. Or that 99.9% of the responses will be 200 responses, so everything's good. And the nice and interesting thing, which is really part of the culture that we have internally, is that we never try to have 100%. Never. None of the Google products have a goal of being up 100% of the time. We might have 99.99, like 5 and another 5 nines availability, but we never even try to do 100%. Because that would mean you could never change anything. And that would be a risk of breaking that promise. If you promise 100%, you don't deliver on it, that's not good either. So if you subtract the SLO from 100, you get an error budget. And like any budget, you need to manage that. You need to consume it, and you need to manage it. And you don't want to go over budget either. So it's defined for a period of time, obviously. It's a critical part of what SREs do. And if you burn through all your budget, well, you stop deploying, and you fix the reliability of the system. Stop deploying new features. If you don't use it, that's also not good. I'll take questions towards the end, sorry. SLO, service level objective. And so, it's really important that you use that budget. You don't want to promise or have people get the impression that you get to 100% because you haven't been deploying recently. So you really want to consume that budget. You want to try more, do more experiments if your budget is still available. An SLA, while most people know what that is not really an SRE concept. This is not something we deal with as developers or even SREs. That is something that is a business translation of an SLO, probably less ambitious than an SLO, but that's kind of different. Okay, let's talk about versioning. Versioning is really important. You might be deploying, you might be building multiple times a day. How many people build multiple times a day? Good. Each of these builds, if they go through all the testing, might actually end up in production. You might have continuous delivery. That's great. What's even better is that you can have multiple versions active at the same time. And the reason you would do this is you could have canary deployment, or you could have A/B testing. So deploy a new version of the app and just start sending 1% of the traffic to it, and look at the logs and see if everything's good, and maybe increase that 1% to 5% of the traffic, and eventually, move the entire load to that one. And of course, you want to have easy rollback. If something goes wrong, just roll back to the previous version. That's really important. You can also use that technique for A/B testing. So you have an app that has two versions. One app, is a shopping cart that will offer free shipping. The other one is 5% off. You just want to see which one works best. You could totally do that. You should be able to do that without having to code this. This is something that should be provided by the platform, the underlying platform. We have testing going on at Google all the time, on search, on maps, on all of these things. Chances of you hitting what we call experiments is actually pretty high because we run these all the time, and that's how we drive most of our decisions internally. So the tools we have, certainly in Google Cloud, is an implementation of all these SRE concepts. So let's see. You need to have logging. You need to have error reporting, and hopefully not 25,000 copies of the same error because it happened 25,000 times. You just want one, and how often it's happened. You probably want to have logs. That's obvious. Traces. A call comes in, a user comes in, and there are a number of calls cascading, some in parallel, some in a serial manner that happen. You want to be able to trace this and understand why something is happening. You want to see all sorts of metrics. So these are the tools that you should be able to, you should expect. So let's actually move to a demo here and see, how we're doing with this guy. All right, this has been, so somebody has been taking a picture of the room, of himself, and we even know who it is. More pictures of a room. Okay, so looks like it's working. And for each of them, you can have a number of attributes: red, design, table, interior design, room, device, media. So you could go to the tags, and here you have the list of all the tags, and you maybe want to click on one, and oops, maybe it wasn't a good idea after all to touch my demo right before going on stage. All right, we'll see how we can fix this. But keep posting. It's fun to see these. I also have my admin tool. So I can see all the photos that have been posted, and I can filter them, I can delete them, and I can see things that have been actually flagged as not safe to show on the screen. But I'm going to do it anyway. For example, this picture here might be violent. Should I show it? That was just my dessert the other day. So I'd rather have this and publish it rather than something that really shouldn't be on screen. So part of the things that I have is logs. Of course, you all want logs. And you don't really care what server it's on. You don't want to have to worry about clocks being synchronized. So the logs actually make sense in the order they come in. You want all this to be taken care of. I don't care where it's running. It could be in a data center in a different time zone. There should be one time zone that I look at. I could change that, but I want everything to make sense as I read it. I obviously want to see summaries, I want to see details, and I also want to be able to see things such as execution IDs, and so that I can look at things like traces. I can see in a different environment here. Let's reload this. All the requests that came in. I want to see, for example, if I take a span that's a bit longer, 4 hours, that most calls are really short. Some calls here are really long, and there seems to be a trend here of getting calls around 3 seconds here. And these are the API picture calls, which is the part where you post the picture. So it might be something fishy here. We'll see. I could look for a specific pass. So every time I delete something, so here are a few examples. If I click on that, I see typically that I'm talking to the data store, that I'm deleting this, and that this is, bound by begin and commit transaction. But going back to the global thing here, clearly there's a problem. It used to take a lot less time, and now it's taking something like 3 seconds. So let me zoom in. And yeah, they're all about the 3-second mark. So I'm not sure what's going on. Actually, I think I got an email, so a notification. I got it here on the phone, so let's see if I can find it here. And yeah, there's this error that is reoccurring. It's called Java lang exception. I'm a fake exception. Okay, let's see the error. What's going on here? And so so it happened 28 times. So I don't have 28 emails coming in. I have one because I had actually previously marked this error as being resolved. But it's happening again. So we open it again, and you see how often it's happened. So we've had 18 people click on it in this demo, and I may be responsible for a few clicks. And here's a stack trace, and this is where it happened and how often it happened, and what triggered it. You know what? I think I know what happened. App Engine has this nice feature where you can have multiple versions. These could be anything. That version could be a build number. It could be anything. And I have this thing called bogus, and that's the one that's getting 100% of the traffic at this point. So I could do split traffic and decide that this is not getting only 100%. I want the current version to also get 50%, so 50-50. I could say also that Coral gets 25, and then any rule could go. But for the sake of time here, I'll just migrate all the traffic to current. And this might take a few seconds, but really, as a developer, I don't have anything to do. There's no load balancer to configure. There's nothing that I need to do other than decide that I want all traffic going there. So if I go back to the app here and reload, do we have any new pictures? No, people are shy. Let's see if the app is deployed. And go back to tags and click on one of them, product or technology. And oop, it's working. Yeah, I guess I should not have deployed a new version just before going on stage. But the nice thing is I can roll back really easily. And I can see the pictures that are all tagged with, what did I choose? Technology. So now you can go back to the app. Everybody has this version of the app, and you can click on any of the tags and see if there's anything interesting. Design, interior designs are fun usually. Kinda. Okay. Not the best example. This must have been another conference. Yeah, so, but really what matters, remember what I said about SREs? The SLO part? Where's the SLO here? Well, it turns out we actually have a tool to track SLOs. You can define, before you get to an SLO, you need to define an SLI. So in this case, I'm looking at the latency. And I'm looking at the latency that needs to be less than 2 seconds. It's not bad. It should really be less than 2 seconds. But if, in this case, I had to actually introduce a 3-second lag, this is why everything was showing as 3 seconds. From that SLI, you can derive an SLO and hope and promise to yourself that the latency at the 95th percentile will be less than 2 seconds on a rolling period of 1 day. And you can see that go down, and actually the problem is that I haven't refreshed, but with all the thing we've been doing here, you should probably see this go down quite dramatically. And also, some recovery should happen at some point. What's really important here is that eventually you see the error budget go down. So when do you wake up somebody? When do you wake up an SRE? Well, when the error budget goes down, when it's going down so quickly that you will soon be out of budget, and you need to roll back stuff as I just did. This is really what matters, I believe, because these are the indicators that matter to your end users. So the ability to manage SLOs in a graph like this one, so you actually know when to wake up somebody or do something about the system, as opposed to things can go wrong. You know, we have failing disks all the time, and if it doesn't have a business impact, somebody will fix it later. Or at least that's how we look at it. So let's maybe go back to slides and close, because I think we're running a little bit out of time. And so the recap is as follows. So no ops, first of all, is not a better term. If you want to make friends with ops or SREs, don't use that term. Not a good thing. I used to think it was a good term. I mean, yeah, I don't want to manage ops, so it sounded good. It's not. Serverless and microservices, if you've tried them, you know they come with some unique ops challenges. You know, there's so much going on left and right. You've broken your big monolith into smaller pieces. There are events being fired. You know, all of a sudden you're in a state you don't really know what happened and why you got there, because this event fired triggered this, which created another event, and there was some auto-scaling in the process, and then some failure. And what happened? It's really hard to understand if you don't have the proper, culture, the proper infrastructure, and the proper tools, and the proper people to operate this. But this is really what's captured in the culture part. In the case of Google, this is all SREs. Again, that's really how we implement this. I've really scratched only the surface of SREs. There are entire books written on the topic, lots of material. I have a few reference slides after this. And any tooling you might see or as being magic might be, but if it is magic, if it's only because of the opinionated runtimes and the underlying infrastructure that it uses. Otherwise, pretty graphs are just pretty graphs. So I'll leave you with this. These are the 2 SRE books that have been published at O'Reilly. They're actually free to read online, but you could buy them. They actually make for good gifts to colleagues. The second one came out just a few months ago. I'll leave it just a second if people want to note this, and I think the talk will be online, and you might get to slides, and if not, just hit me on Twitter, and I'll share the URL. The other thing I want to share is this video series. They're really short videos, just a few minutes each, and they compare SRE and DevOps. You might know DevOps, you might understand the principles. This is how DevOps translates into the Google world in the form of SREs. And it's a really fun series of about a dozen videos comparing the two, and I highly recommend that you look at those if you thought this was any useful. So that's all the slides that I had. There are a lot that we could say about functions, apps, containers. I think the future is exciting with things like Knative, that's providing a serverless infrastructure on top of Kubernetes and a serverless experience to developers on top of Kubernetes. So again, there's a talk by my colleague Ray that I encourage you to attend. And look forward for a number of announcements in San Francisco, which is this pretty picture, in April during a conference called Cloud Next, which Google is hosting, so in a couple of months now. It's scary how close it is given everything I and many others have to do before that. So with that, thank you very much. Maybe we can actually take a few questions. We have 5 minutes, and the way it's going to work is you're going to shout the question. I'll try to listen, understand, and repeat. Is that how it works? Okay, great. Do you have any questions for me? Anybody? And if you have questions, you'll get a beanie, a nice Google hat. Here's one. Somebody wants a hat.
Possible to mix function calls from different cloud provider services, or is there any use of doing that?
So the question is, can you mix calls from different service providers, from functions or APIs? So in theory, yes, absolutely. Some people do that. One of the problems you might see with that is that the tools that we have, so I didn't mention that the overall tools for monitoring and managing and all the SRE principles are called Stackdriver. They do apply to AWS and Google Cloud. They don't work with Azure, for example. So the one limitation might be that tools like this are not able to monitor the full architecture. The second thing is that you're going over the network and typically the internet, which might come at some cost, both monetary cost as well as performance cost. But it's very much doable. I recently wrote a quick article on how you can drop a CSV file to a bucket and have a function populate a Google spreadsheet. Somebody else had written the exact same. I found about it just the day after I posted. That's always how it happens. You know, how an AWS Lambda can do the same and, you know, get data from a database in this case and update a sheet. So, which typically is using an API, which is Google Sheet API. So you can mix and match many things, yes, absolutely. Especially in the world of glue development, where you're just gluing pieces together with functions. Come and see me afterwards, and I'll give you a beanie. Or come by the booth. We have a booth and many beanies.
How much time it took you to create that app?
It's hard to tell because it was the two of us. Actually, it was more Guillaume than myself. We're not front-end developers. That's the problem. So, you know, this is built with Vue.js. You could see how limited it is in terms of UI, and yet it took us more time than we would like to admit, probably for the front end. The back end is easy. The back end is like the server. Maybe I can quickly show this to you. They're really there are two functions. They're written in Node. They're really not all that long. So vision analysis, this is where you listen, it's deployed, it says the trigger is a bucket called raw pictures, and the source is really not all that long. You know, it's 80 lines. And 80 lines, you call the vision API, you ask for labels, image properties, and is it safe to show? You know, and then, you know, there's actually even some error handling. So it's fairly short. So it's hard to answer. I'm probably not answering the way you expected, but it's two functions. Oh, and one thing I didn't mention, which is probably worth mentioning, the way we define regular calls to one of those functions to calculate the API, the tag of the cloud of tags. I'm sorry. Is through something that is really a cron as a service. So you could decide that every hour, every 5 minutes, every Monday at 8 o'clock, you call this API or you do this. And that's really nice, nice to do. So two functions here, and app engine-wise, it's Java code, mainly for the front end. I don't know how quickly a good front-end developer would have written this, but it's not very long, to be honest. It's a demo also, to be honest. One question.
Is it clever to share like SREs among teams? For example, if you have one microservice team and one data engineering team, share.
Oh, okay. So would you share? You know, there's scarce. Those SREs are scarce resources. Is it worth having? Is it possible to have an SRE that looks after two products or two different teams? Very much so, yes. As long as they've been involved early on in the process and they understand what they have to manage and the infrastructure they have to deal with. If they have the cycles, if they've automated themselves out of the job, chances are yes. Hopefully they'll do that. Otherwise, problems don't happen all the time. Outages don't happen all the time. So they have time to help build other products, help ship new features, and work on multiple teams. That is very much possible. And I think we're out of time. So thank you very much. I hope you have a great conference.